Well, this is Old Electronics Fan, and this is the United American Bosch radio. I cannot find anything on this radio. It doesn't even have a picture of it anywhere that I can find. I've looked in all of my resources, and none of them have this radio. It's pretty bizarre. It looks like somebody has replaced the fabric for the speaker. I don't think that's normal or original. But I don't know because I can't find any pictures of it. It's kind of ugly, as you can see. It's kind of a different design there. It's got some decorative work here, but I think it's like a pressed board material. So that's different. The case, it's got some issues. This is, oh, by the way, I didn't point it out. On the front of it, it's got a partial label saying that this is an American Bosch. The interesting part is if you go looking for just American Bosch, when you're looking for schematics, you won't find anything that entered in under that. You will find it under United American Bosch, so it's rather interesting. So we go down here, and it shows you, let's see, zoom in a little bit, United American Bosch Corporation, Springfield, Mass., made in the U.S. And this is model 897CW. Now, usually it will tell you somewhere that it's a super heterodyne, and this one doesn't say that anywhere, I don't think. But I'm thinking that it might be. 1, 2, 3, 4. It's a 5-tube. It's had tubes replaced. This one is not original. I don't know what's hiding under there or the other. Trying to figure, and it's got an electrodynamic speaker here. Ew. That's not kind. Usually there's a connector on one end or the other for the speaker wire, and if I were to guess, I would say you'd have to you would have to unscrew these two. You'd have to unscrew these two nuts here. Take this off, and you probably have connections that you have to undo there to get that apart. The output transformers on the speaker, not unusual for that to happen. This thing's been sitting for a very long time, and I'm trying to guess the age. If it's super heterodyne, then I guess that it's in the mid-30s, maybe. Maybe late 30s, I'm not sure. There's no dates anywhere on it. Like I said, usually there's a tube chart somewhere, but I don't see that. One of the things that makes me say this is newer, number one, is I can carry this by myself. It's much lighter than some of the older RCA R35, R51 models. The cabinet is definitely more lightly built. The R35 cabinet, man, that sucker is solid. So I think this is definitely newer. Those are around 1930, 1930, 1929, 1930. I would say this is at least 35, somewhere in there, I'm guessing. Maybe I'll find some date codes that will help me sort this out. So what I'm going to do now is I'm going to take the speaker and the radio out of the cabinet and put it over on the workbench and see what we can find out. I'll be doing this without a schematic of any kind because there isn't one. So anyway, well, here it is on the bench, and definitely filthy. When I pulled this out of off the shelf, there's a nice little opening down here, and Critters has made a home down there. Oh, a little bit. So this looks very basic, very rudimentary. I don't see. Okay, well, there's a capacitor box here. Looks like these are replacements. Yes, that was. Yeah. So which one is which here? I won't dare remove them until I know where they go. Well, yeah. This is an 80. That's our rectifier. 47 is an output tube. I hope that you're fine because it's pricey. If that tube is bad, I may use tubes I borrow from another radio to try to check this out. But if that tube is toast, that, as far as I'm concerned, is going to condemn this radio because it's not worth. It's not worth the cost of that tube. Let's put it that way. A lot of people. This is kind of sad to me. A friend told me that a lot of the R35 radios and others that use the have a separate amp using the R47, using the 47 tube. People are taking the amps out of the radios and disposing of the radios because all they want is the amp. I guess the amplifier used in those RCAs and maybe other things, but in the RCAs in particular are nice and have good sound, and they actually do. But it's kind of disappointing that people would toss a piece of antique equipment just to get the amplifier. But anyway, so this is the speaker, which is in absolutely beautiful condition, and this has to be a newer radio speaker. Oh yeah, that's good. The spider in this is metal, not paper. A lot of them are paper, and this one is not. So that probably tells me that it's newer. Let's see here. Set you there for a moment. So let's go back. Let's go back in here. What does it say? That doesn't help me. Oh, yes. It's something else I didn't notice when I was taking pictures of this. Let me zoom in a little bit, because this 55 tube has been crossed out, and it's got a I think it's a 2A6. I think that's what they use. So, I'm trying to remember. Well, anyway, I'll look into this further. But that means that they replaced. This is a 2-volt tube. 2.3, whatever. I forget what it is. And the rest of them might be 1-volt tubes, except for this one. Oh, this one might be 2 also. I have to look at my tubes because I'm forgetting now which ones are what. Let's find out if this is our tube. Something tube. And you can't. Sorry for the arm. Yeah, it's a 2A6. So this tube was not what was originally intended for this. The fact that it's been crossed out and stamped leads me to believe that the factory did that, but it wasn't somebody who did that after the fact. And this is the second old radio that had a mix of tubes in it. Let me just check something here. Well, actually, let's look underneath. Maybe I can find out what I need to know. So, oh boy, the wiring is shot. The insulation on these wires is just gone. Yeah. So there's a number of things. The volume control has been replaced. I have a feeling that the volume control that was on here had a center tap. They've disconnected that. When I took this out of the case, this is how it was. So somebody's unhooked the power cord. Excuse me. So let's look, see if we can see under here. Oh, yeah. I don't want to do that. Take you out for a moment. Don't want to stress that socket. Okay, so interesting. So let's see. So we've got a black and a brown wire. Oh, we've got to get up there better. So black and brown wire that are coming from the pilot lamp. And let's see what you are. Not telling me. Not telling me much. Well, we'll have to dig into that later, find out what that is. But anyway, so this tube in the back is tied. Well, filament wire is going to. Interesting. Well, arrow box. It looks like it might be a capacitor. Let's see here. All right, let's go to. What I want to try, what I'd like to try to find out, and it doesn't look like it's going to be easy to do, is see if I don't know what that is. It might be a capacitor. It looks like it might have a coil on the outside. I'm not sure. I'll have to clean that up a bit. This is where it's going to get interesting, because I have components that aren't really labeled as such, and so I don't know the value. I don't even know what it is. I mean, it could be a capacitor, just a capacitor. And it kind of looks like this is a replacement for something else that was here. Joy. Alright, so that goes to this tube, which feeds to this tube, which goes down to that tube. I think all the tubes in here are 2 volt, as far as I can tell. And these are definitely not original. Observe polarity. Yes, that's very important. If you forget and don't pay attention to that, bad things happen. So, let's see, where is the power cord coming in? It's here. Oh. Alright, well I know why this was unhooked. The volume control they put in had an on-off switch on it, so they decided they opted to use that. Yeah, I'm betting they're both 20s. They were probably smaller than that originally, but when you're dealing with filters, it's not horrible, as long as it's not excessively large. You can put larger ones in. So, does the volume control rotate? It does. Yep, and the switch clicks. Alright, so what I want to do, if I can, is There. All right. So what I'm going to do right now is we'll do a little poking around. And we're gonna and all right. So the power cord says that it's on, or the power switch claims that I've turned this radio on. That's not healthy. Well, it's not shorted, and it looks like there's something connected to it. Yeah, that cord has had it. Alright, so far that's good. Let's check this out if we can. Okay. And that feeds to, well, that's the on-off switch. So this is the primary. Let's see. So this and can't quite tell. I hope that light wasn't shining into the camera. I didn't notice that. Was it? I don't know. Okay. Well, let's see. Let's do this. I want to know. Yeah. Let's find out, if I can, which one is which. That looks like that's one wire. Now, what's interesting is that this other wire goes here and then goes over here. And that leads me to believe right there that that switch is not working. Yeah. Let's see, I don't know which one is which. Let's check. Yeah. So this. Alright. And so this one. Yeah, that switch is not working. It's a big shock. I'll have to fix that, but I can jump that and see where we're at. But now. Okay, so this is actually acting as a terminal strip, it looks like. You got a wire here and a wire here, and this is one side of the power cord, and this is the other side feeding into this. And I think I remeasured that, and I think I came up with that it's not shorted. 9 ohms, yeah, that's good. Now, I should have, that shows me that's one of the electrolytics that was connected. Well, let's just see. That does not look good. Oh, actually I know it's okay. That's okay. This is okay. Yeah. So interesting. Very. This wire goes out to the speaker. It's got a capacitor across that. Okay. Oh, here's another. This looks like another replacement capacitor, maybe. All right, so here's the part that concerns me a little bit, is what I'd like to, what I'm hoping, well, what I should see, yeah, this is not great. AC, this is just a connection that doesn't have anything to do with the transformer as far as I can tell. Oh, okay. Oh, alright. Didn't notice those down there. It's focusing everything up on here. Okay, so these go down to the rectifier tube. Okay, 700 ohms. And there should be a center tap for that. Come on. Yes, okay. Yep, alright. Not exactly the same ohms, but it's close enough. So what was that one down there? One was 380 and one was 357. I've seen that before, and it seemed to work all right. So, okay, so these two wires are for the B+. I need to have, there should be a, that one, that's a filament, and that looks like a, where are you? Can't tell. Huh. Well, I really need to get those out of there. I need to check them anyway. Although all I have to do is plug it in and it'll probably hum at me quite nicely. Let's see here. Where can we go? Well, I think some of these are, two of these are for the filament here, and then there's got to be two more, which I think this one feeds one side. Like I said, usually these are center tapped somewhere. I don't know if this goes to ground, so that could be center tap, but if I had to guess, I'd say that this is the V+ and the center tap for that. So that takes care of those three. Got 1, 2, 3, 4. Now, this filament won't be center tapped. I'm really hoping that this one is, but I don't know where that connection comes from. Because I have 2 for this and 2 heading down to that tube, and I'm pretty sure, yes. So this one and this one are the filament, 2-volt filament for this radio. So everything in this radio is 2 volt. All the filaments are. So I'm assuming that means that that little bulb is too. Let's see about that. But okay. So interesting. Right, so this is probably the antenna. So if you look up here, that wire goes into this coil. I'm assuming that's the antenna coil. And we have a resistor across the capacitor here feeding the... Huh. That's interesting. I'm definitely going to have to look up and print out some tube information so I know what the pins are and where the filaments are. Usually the fatter pins are the filaments, and that looks like that's the case here. Interesting. Then you've got this going up here to that, and I don't know what that is. Okay. So, other than the replacement capacitors under here, and possibly this, where are you? There's a capacitor somewhere, I just saw it. Right there, there's a capacitor down there. And that looks like, I can't tell, but it looks like it's connected to the transformer for some reason that I can't fathom. Yeah, that's soldered, has solder on it, and I have a feeling this little capacitor goes there. Why? Oh. Yeah. I think that goes between, I think this capacitor goes between the AC and ground. I don't want that in there. I have no idea what shape it's in, but I'm pretty sure it's not healthy. So we're going to dispose of that right now. So I really don't want that. Given its age and how bad it is looking, I don't want that there. And I don't care if it's a little bit noisy, it's going to be humming enough. Alright, so I think where I want to go from here, well, let's see, what do I want to do? I am thinking, maybe I'll leave that, well, I gotta do something, this cord hasn't shorted out yet, from what I can tell. So, we're going to go crazy, and I am going to have my light bulbs in circuit. So if it is shorted, we'll know, and that will take care of that. Alright. Let's see here. Let's put that in, and there. Oh, leave it there. I don't think this tells me how much current it draws. Nope. Alright. So, I'm trying to remember. There was a radio. What was it? Browning. It was a Browning 35. Also, it had a Toby Turner. And that one, that was actually a kit radio. And it had the transformer, and it had 3 windings, if I remember right. I think it had a 6.3, 5.5 for the rectifier, and a 2.5 for the 2-volt tubes. And somewhere in the course of its life, one of the tubes that was originally a 6-volt tube had been replaced with a 2-volt tube, and then whoever had made that change had rewired the socket for the new tube so that it was getting 2 volts and not 6, which is kind of a good thing, because you really don't want to do that to your 2-volt tubes. Feeding them 6 volts is bad. So anyway, so here's what I would like to do. I'm going to jump over that switch since it's not working. Deal with that later if I feel so inclined, but for now we're going to get rid of that. And yeah, this is AM only, not a surprise. I mean, these are IF cans that are adjustable, so I'm assuming that this is super heterodyne. All right, so I've done some basic checking. It seems obvious that this is not shorted out, and let's see here. Okay, let's check our transformer voltage first. So I'm going to do this. That's on. So I get, oh boy, that's no good. Yeah, no good. We have a short somewhere. Well, if I turn this up, it's got a short. So let's check. Yeah, that's never a good sign. So because the switch wasn't working, I'm not sure what my meter was reading before, but whatever it was reading was not right. All right. So here's our. Oh, I want this on ohms. This says 9 ohms. So why is that? Hang on. Either this is just drawing a lot more current than I expected, because that's only, well, it's a 100-watt bulb, but it's an energy saving bulb, so it's already only about 75 watts. Well, let me see if we can get this out a little bit. Got too much junk in here. Alright, so I have my little control panel. I'm going to add another bulb in there. And we're going to see. And I'm also then going to see if we can tell if you've got, we're getting voltage here. And so, and we need another one. There you go. So if I've got a short right up front, either in the primary or secondary of this transformer, I'm probably not going to see voltages here. This is an AC, which is what I want. Do this. I don't have any voltage. I should have volts there. I don't. Well, let's make sure that I've got volts here. Alright, let's do this. Oh, you know what? Oh, gee. Once again. Alright. Okay. So, try number 2. I am forever forgetting that when I remove the power plug, to put it back. Okay. try to again. See what's the current. 1.5. It's half an amp. Let's keep going. Still. Well, let's turn another bulb in here. Uh-oh. Maybe this. I have a bulb going south, I think. Why? Some of the energy-saving bulbs are less than long-lasting. Yeah, that's the 75 equivalent. It looks like it may be headed for. So I'm at 50 volts. Yeah, that does not look good. I'm not hearing any buzzing or humming, but I don't like that. I don't know how much you can tell about those bulbs, because the camera's probably messing with that. But I've got 1.2, I'm at 50 volts. That bulb is going away, so let's see if I have another one of those. 75 watts. Ooh, this is an actual 75 watt. Let's see. Alright. Let's go back up. And yeah, that's not good. I don't think. See, now I do not have the rectifier tube in there. And that's 3/4 of an amp. Dare I? That's not quite 1 amp. Is it really? Does that really draw that much current? I should have more volts there. Something is not right. So I'm at 80 volts on that. Although this isn't saying anything. All right, let's kill that for a moment. Okay. My kilowatt easy was not showing me anything, and that usually means that it's below 40 volts. Okay. Back that down a little bit. So let's see, do we have voltage? There's an AC. I don't think this transformer is healthy. It said it had ohms, but that doesn't seem right. So have I got this wrong? There's one leg. Oh, from here to here. Let's measure. No. So this feeds over there, which goes there. That feeds to there. Well, this may be a very short video. I am going to I think, what do I want to do? Alright. So I unhook that, it's not connected to anything. This is one leg of the power cord. This is one leg of the power cord. So that means this and this are primary, which makes sense right there. Alright. Go. Now, let's go back here. Still seeing 7 ohms. Let's put this on AC volts. I know I'm not going to get anything anywhere over there. I'm just double checking. I supposedly have that power switch jumpered. Oh, let's see. What? Really? Well, I'm glad I checked that. Yeah, I don't have any voltage there. And I should. Why don't I? Well, something is definitely not adding up. And I think I may have to just put a different cord on here. Yeah, it would make sense anyway. Okay. Well, let's start with this. Yeah, all right, fine. Let's go there and there. I don't care. Do this. And this is going to be on ohms. Really? Oh, it's one thing I'm not used to yet with this. Okay, so that is working. So let's time for a new cord, I guess. Now, I can't imagine why there'd be any problem with this. But anyway, time for a new cord, and we'll start with that. And then maybe, just maybe, we'll get somewhere. Okay, new power cord. Can't imagine what happened to the other one. Let's try this out. So, let's turn this one off. You get lots of volts. This is good for 1,000 volts, so, oh, there we go. So if this is on current, current's way lower, of course, 90 volts. My pilot light's coming up. I have voltage here. And this is typical of these old radios. You get 700 volts. Thereabouts. So, my pilot light is lit, which means that I'm getting filament voltage there. Can I see, are the tubes lighting? I don't see. Huh. Okay, so I see 47 tube is lighting. I'm at 120, so they should all be lighting. Yes. Alright, so what I'm going to do next is what am I going to do? Well, I think I want to figure out what will be my B plus, and that should be one of these two. Should be my B plus. Let's see. Should be. Okay, there's a. This is a line that goes up to the speaker. Actually, what I'm going to do, what I want to do is I'm going to print the tube information for the tubes I don't have information on, and then I'll just check the plate or plates of some of those tubes to see what we've got. I have a nasty feeling that we may be lacking some working tubes. Actually, let's just see. Let's see if my theory about the Now, well, let's say I'm surprised. I'm guessing that where was I headed? I don't know where I was headed. It left my mind. Well, this is one of the tubes that didn't seem to be lighting up, but filament seems to be okay. And the output tube was lighting up, so let's should be grid cap. Yes, those are all grid caps. Pretty common. Alright, well, we're going to put this tube back in, and I'm going to flip this radio around. Well, actually, while I've got this out, let's just check this and see if we've got a working tube. If not, I should have one. Yep. Okay. So, so what I want to do then is flip this around, so I don't want it resting on the tubes. I guess that'll work. Staying all by its lonesome is good. Okay. All right, but I still want to get. Well, I probably should be able to read it from there. Read it from there what the B plus is. So maybe I'll do that. What did I do this? Okay. Doesn't matter. Alright, so hook that up to, and it does, because there's a ground right to the chassis, we're going to assume that chassis is our B minus, and okay, who knows if I even have a working volume control or anything else, but well, why not? Yeah, so that should be B plus, because it's probably going to feed up through that back into the radio and then feed in elsewhere. So now start off low just because. Alright, let's bring it up. Right about 90 should get me. So my light is lighting up a little bit. Film is lighting up. I don't have any volts. Well, let's get this out of there. And should have filament voltage at least 3.3 volts. I would have thought that was 5 volts. Four volts. Okay. Okay, looks like I've got, and I don't know why this is freaking out, so we'll use a different meter. Yeah, I know it's high voltage. Stop beeping at me. It's supposed to be good for 1,000 volts. Don't give me any grief. I'll play with that later, try to figure out why it's misbehaving. Let's see, there we go, and I want that. No, I don't want that, I want that. Alright, so let's try this again. That doesn't look good. And theoretically, if I go here, That's millivolts. Let's see. Oh, wait a minute. B plus was, oh man. Oh. Yeah. If you select the right thing, you get the right thing. Yeah. So what I was doing wrong was I had to set on AC, not DC. So so my rectifier tube is getting warm. That tube's getting warm. That one actually is lighting up. I have no sound coming out at all. So it could mean there are other things wrong. But at this point I've got my filament voltage. I've got, so back here, let's see what my filament voltage is. Just out of curiosity. Yeah, 2.1, okay, that's appropriate. So, yeah, the wiring is not great in this, at least not in the wire there, it's not looking good. Yeah. It's possible, because I've got, for instance, when I look at stuff like this, it makes me nervous. Right. Right there. That wire, I don't know if it's shorting against anything. That goes to one of the cans. In fact, all the wiring for both cans is pretty sketchy. Top and bottom, it would seem. I've got this wire that has no insulation anymore. Let's see. Now, so it's possible that I either have a tube that's not working, or drop this down. Or one of these wires that goes into one of these cans or someplace else. So we've got wires on the bottom going into these cans that are not healthy. Well, that doesn't look like it's riding against anything up here. I've got this wire going down through the chassis. Goes down through the chassis. Let's take a look at that one. So I haven't checked the output transformer. The fact that I was getting voltage on this wire means that the field coil, so I checked my voltage here and I had voltage there, which means that the field coil was sending voltage through it, so that should be fine. I think. Actually, maybe not. Let's see. Well, there are a couple of things I could do. I pull this off, I can, well, let's take a peek under there. Oh, come on. Alright, so let's take a peek under there and see if I can figure out what goes where. So theoretically, I'm trying to remember in my head. I'm so used to having a schematic. I'm kind of flying blind, but that's okay. Good experience for me. But if I remember right, the well, let me finish my thought in a minute. I gotta look at this. Can't think and look at the same time, apparently. Yeah. So, yeah. Here's what I understand. So we've got this brown wire right here. Comes up here, goes through the field coil, comes out of the field coil, feeds this blue wire which goes there. And then this blue wire also feeds one side of the primary of the output transformer. And we have the black wire which goes down here and comes to the 80 tube. So how this works is that voltage I measured here, that just tells me that the field coil is okay. I need to know whether this is okay. So let's find that out. Let's see. And so my other meter wasn't bad. Nothing wrong with it. It's just the operator. Okay, so let's see if I have. Uh-oh. That's no good. Yeah. Bad output transformer. That's not ideal. Yeah. Yeah. And that's not going to help me because it's going to be across the speaker. Come on. Yeah. So, the speaker and the transformer, who knows which one of them is good and if one of them is bad. But it sure looks like this is my culprit. Yeah, I don't think, well, I guess it wouldn't hurt to move that around to see if I get any response, but I'm not hopeful. Yeah, that's not good. Okay. So I do have a universal output transformer that I can substitute and see if we can get some life out of this speaker. Because the other way to find out if this was good would be to check the plate of the 45 tube. Well, I'm pretty sure, now I know what I can find. There won't be any V plus voltage on the output tube. So now I got to round up my other transformer, and we'll see where that gets me. Kind of disappointed. Yeah. Well, let's see. Can I? What does that do? Oh, somewhere I should have cable for that. Right here. We're going to try something. I don't know if my function generator puts out enough to do what I want to do. Well, let's see what that does. And output. Yep. Okay, so my function generator tells me that my speaker is okay. And now, so it definitely seems, oh, actually, let's do this. It's kind of a double check to see if, no. So if I go here, nada. So that confirms that's a dead output transformer. And I had originally thought I would use this on another radio because I didn't know what I was going to do with this. I don't know if I have any other transformers floating around. I have to look. But I can use my universal transformer to get some values from that one, which then could maybe help me find an alternative transformer that I've got kicking around that might work for this. Joy. So, depending on the results of the swap here and how this behaves will determine whether I go any further with this. Now I had thought that this power transformer would be something useful to have around, but given that it's only a 2.3 volt filament on this, and it does have the 5 volt filament for the 80 tube. So I guess all I would really need would be a 6 volt transformer for the radio that uses 6 volts, I guess. So I guess there's some value in that, maybe. But for right now, we're dead in the water. Okay, well, I do have this universal transformer, and this is the paperwork that came with this. And, well, I mean, the information up here is good. I found the 47 tube in here, which says it's a 7,000 ohm impedance. So far, so good. Because there's my tube right there, 47. But then you come down here, and they list all these numbers down the side, and then these are the different connections that you're supposed to use, I guess, depending on the speaker. I started looking around for any of these. It's been so long and this page is yellowed. None of these are listed for what they probably were originally. Other things now have numbers the same or similar to these, and then sometimes they aren't even speakers. So what I did was, let me show you, and hopefully this makes sense. The best thing that I could come up with was, let's back out a little bit here. Alright, so this is the speaker, this is the transformer, the secondary side of this is good. So if I measure the secondary on this, 0.4, okay. Now if I measure this, no, 0.4. I think that's the closest I can get to this. Stop it. Why are you doing it? So here's the thing. Back up. If your transformer it doesn't have the right values for the speaker and the tube, your output tube, then it's not going to behave as well as it might, and chances are it's probably going to distort. That's interesting. Oh. Well, anyway, so obviously the instructions there weren't giving me what I wanted. This is the best thing I could come up with. Of course, I have no idea if this thing does anything. So now I've got everything tied. This was set up so that on a single output, both black wires are used. If you have a push-pull, I think one black wire, no, the black wires get tied together, and then this goes to the other side. So anyway, now let's find out what we got. So I'm watching the bulb dim down over there. Start off bright. And we don't seem to have any output at all. Nothing. Well, it's 120. That should be. All right. I do have. I was going to look up the tube charts for the other tubes that I don't have charts for, and I forgot. But I do have the 47 tube chart. So, because that belongs to one of my radios anyway. Okay, so plate, filament. So plate should be so much fun. Let's see. That's supposed to be 47. Come on. Let's get you out of the way if I can. So filament. Oh. That is not the right tube. There's a 45. This is supposed to be 47. I have the wrong tube. I think. 47. Well, that is not going to work. So, there. Okay. Well, I'm going to look up those tubes that I was going to look up, and then I will have all the information I need, I hope. Alright, so I printed the correct page this time, and I think I did check, that is a 47. So, here is okay, so this is, I believe, the input from, or is this, I thought this was input from, it is, this is coming from the rectifier. Now, following the chain, if I go here, I have 600 volts there, and then I have, come on, what? That's not right. That's 430. I should be able to go to the other side here and get volts, except that I don't. Why? Once again, something isn't right. Well, let's check, make sure my field coil is indeed working. I thought I had that. So this, and this is my field coil. I'm just going to unhook this and unhook this. I just want the field coil. Oh, I'll stop it. Oh boy. I thought I had measured this and I got what I wanted. This does not look good. So I have a bad field coil as well? Really? And there's nothing. Well, that's no good. There's a way around this, but I don't know why I was getting voltage out to this wire from this before, which would imply that this field coil is okay. However, it doesn't seem to be okay now. This may be a total loss. It's a shame because that speaker's in such nice condition. Okay, now, that will not help me at all, I'm pretty sure. Okay, so, when I measure here, I have nothing. And I measure across this, I have nothing. So that means everything related to this speaker is dead. Dead, Jim. And I have no idea what the resistance of this field coil is supposed to be. So, I say so. This radio is looking less and less like something I need. Let's put it that way. Okay, so what I've got to do then now is surprise. Okay, so, and as you heard earlier, my function generator was able to get this, make this speaker make a sound, and some believe that that's because the core has become somewhat permanently magnetized, which it could be. Once you turn on the electromagnet, then it does get louder, usually. In my case it won't, because it's not there. So, so this has to go to here. That has to be a resistor. This then gets fed. So this would have to go here. I have to think some, having to remember stuff, okay, which I pretty much do. So this goes to here, to here. This is connected there, which then connects to this. Because I know that the B plus has to go through primary of this. Here's how it's supposed to work. If everything isn't broken. B plus comes in from the rectifier tube, goes through the field coil, which will be replaced by a resistor, goes over here and feeds to the output transformer, and then this side feeds up to the plate, which is what this is supposed to be. And I'm pretty sure it is. And I can prove that by, see, I'm just trying to make sure, because I'm just doing all this out of my head, and I just want to make sure. Now I guess we can, there we go. Alright, so I'm going to go here, and I go here. This way I'll make a noise, and I don't have to really look. Okay, so there it is. Alright, that's correct. So that's the plate on this tube. This feeds the plate voltage up there, and we're all good. So, there's a 1K. What are you? 2K. What we got in here? 2500, no. I want to find, that's 2K. Typically, the ohms range from somewhere around 1100 and up. Some of them are as high as 1800. I don't know what this takes. So maybe what I should do I have? What do I have? Well, that would be 1200. There's 300. Maybe we'll do that. So I think the thing that will tell me whether I've got it right is when I look at the plate voltage, because at least I've got this, and it tells me what the plate voltage should be, 250 max. So what I will do is tie these all together. I'm going to run out of jumpers, clip leads, something. So that's going to be 1500 ohms. I'd rather go high than low. Okay. And let's see here. Oh yeah, I've got other leads floating around. I can swipe other things. Yes, I'm not out. Okay, so this. I don't know if my color coding is going to help me anyway, but we're going to try this. So now, okay, that's the primary. Okay, this is my secondary, so I have to have a speaker somewhere. Alright. So have I got this right? So I've got to have okay. Alright, so I've got to have alright, so the brown is going to go to one side of the resistor. That's good. And then okay, so this then I've got to do. Alright. I'm going to take my time and figure this out because it's very easy for me to screw things up. So, bottom line is I want, let's start here. So let's just wire this up the way it should wind up being. So this side goes to the other side of the resistor. So, okay. So these resistors replace my field coil. Good. So far so good. Now, I've got my primary here, and my primary has to go across here and here, which is how that is wired. That's pretty simple. Yes, I got it. Alright. And all I have to do is follow this, because so these two leads come from the primary of my transformer. Good. This lead is one side of my replacement field coil. This goes to the other side of my replacement field coil. These two are the primary of that transformer, and so the primary of this transformer is hooked there. And now all I have left is a speaker I need. So, you. All right. Now, let's hook that up. All this so I can find out if this thing hums, which I'm pretty sure it will. And so far I don't see anything under here with any kind of date on it, so that's not going to help me much. And then the last thing I want to do is, as I knock everything onto the floor, is, stay there. Make sure I don't short anything out. That looks good. Get it out of the way. And so I want to set this up. And so what I really want to know is, I want to know what my V plus is. So I'll set that there for now. Okay. Well, this will tell me a lot, and so the one I care most about is this one, because that goes to the plate of my 47 tube. Yes. Well now. So. There it is. Hum. Oh. With a very noisy volume control. So 280 volts. That probably means I need to go a bit higher on my resistors. but it works kind of. And on some radios, they tell you to measure from the cathode to the plate if you want an accurate plate voltage reading. And so, do I have... Well,
the factors were all, that's what we're saying. They were. Even though it ain't all this inflationary pressure, Donald Trump was so good. He kept inflation below even the Fed's target rate. And the minute he left, those same factors, Biden couldn't deal with it all. And inflation...
well now. That's surprising, to say the least. Let's hook this up to the antenna.
Show. Folks, check out my podcast. I will take your calls. Coming up, 844-484-3872. Paid for by Christian Care Ministry. You know, it's true.
Okay, so bypass that, see if that makes a difference.
When it comes to our spending, our health care, this is why many people
we have a volume
share.
Guess we're not going to play with that. Well, the volume controls jump, I think. So, well, this was interesting. I don't know if that failed after I tested voltages or if I just measured the wrong thing. But it's working really well. It sounds very good. The speaker's larger than that one. I don't think I have anything that size. It's kind of annoying. I'll actually have this. Curious to see how big you are. What are you? Well, it's an 8.5, or it is a 10, depending on which way you measure it. If you measure on the inside, it's 8.5 inches. If you measure to the outside of the frame, it's almost 10. So, yeah. And I, just for the fun of it, hooked up my output transformer to this speaker. And as you can tell, it's not very loud, not compared to what it should be. I also have 4,600 ohms of resistance in here. And if I check my voltages now, alright, so go here, here. On you. Well, let's go. Well, that's actually 256, 29. Well, it's dancing around, but I had a pretty solid 250, or 260, I mean. I think here's what I'm going to do. Since that's not cooperating. There. Now you're going to play. Yeah, 259. Well, yeah. So, when I let it play before with the original setup, which was around 1800 ohms, the voltage did drop down to around 280 again, which is where we saw it before. So, but you know, I would live happily with that. So that's just for the fun of it. Now, that speaker, even if it were working properly, I think it would sound a little bit tinnier than it should, and well,
On a jagged step, I just dropped in to see what condition was in.
so I can't let that play for very long. I started experimenting with different positions on this.
In a deep dark hole, and then I followed.
So anyway, so I don't. Well, at this point, I've got this resurrected. It's working. The tone quality is controlled in large part, well, several factors. But you will find, well, let me back up. A lot of American radios, all American 5s, tend to have too much bottom end, and they tend to be too muddy. And there's a way to fix that. You can either remove the capacitor in the plate circuit of the output tube, or you can change the size of the capacitor in the plate output tube. Well, yeah, plate of the output tube. I actually did that with my Silvertone, and I discovered that a particular value of capacitor would cause that radio to overdrive the speaker that was designed for it. And it had good bottom end, but the speaker wasn't really happy with it. So, yeah, there is room to play. I can't remember if I went up in capacitor value or down. Don't remember now, it's been too long. So, the fact that this is a little bit tinny sounding, yeah, it is what it is right now. I finished my story. Okay, where did I leave off? So, I think I mentioned that I checked out his radio, decided that it was beyond hope, which meant that this parts radio wasn't very useful to him anymore, because I wasn't going to be saving it, and as I explained to him exactly what and why, and he decided that it made sense to not pursue that, and so we didn't. So he had this radio sitting there, and I said, well, what are you going to do with it? He said, well, I don't know, I'm going to get rid of it. I said, well, okay, I'll rescue it. I kind of hate to say just go to the dump. And so that's why it's here. But you saw the picture of the case. It's not great. It's not what I call handsome. Kind of ugly, actually. Oh, and then he had another. He had a GE. It was had a '78 record player and a radio, and I think it had shortwave as well. And that one I will be bringing back also, because I'm getting parts for that. So I really, one of the neat features of that was it had a preamp for the phono input, something I've not seen before in one of these old radios. So I wound up with the chassis from one radio, and I wound up with this one and the cabinet. And I honestly don't know what I'm going to do with it. I have no idea if it has any value. I mean, I just don't know. So for right now, I think this is going to go back into the cabinet it came out of. And so I guess this is it. I'm going to wrap up here. I got it to work, which is kind of my goal, and store it away and see what happens next. I have a feeling borrow tubes out of it or something. That's about all I can think of. Although, well, depends on what I actually have. I have an R52, 51. I have another radio that's similar to the R35 that I worked on. I'm probably going to tackle that soon. I've had it for quite a while and haven't done anything with it. So it's probably time to do something with that. It's been sitting long enough. So I'm going to wrap up here really and truly. And we'll see where it goes from here, but I hope to see you on the next one. If you like this, let me know. If you haven't subscribed yet, I would really appreciate it. That helps. And if, comments, make some comments. Let me know what you think. Well, thanks for watching, and hopefully we'll see you on the next one.